Hi guys, we're in chapter 7, section 3. We're talking about trapezoids and kites today. I don't have a kite picture up here, but we're going to look at it in the workbook. So if you have your workbook handy, you're going to want to get it out. And we start on page 399 today. I'm going to switch over here in a couple minutes and bring up my camera so that we can look at some problems and do them together through the camera. Sorry if you can hear my dog snoring. He's laying on the couch next to me, but we're going to keep rolling on forward. So a trapezoid, just so you know what we're talking about, is like this shape. I guess all of these in the top row and these over on the side here, they're all trapezoids. When I think of a trapezoid, it reminds me of the platform that they use in the circus that an elephant would stand on. So has kind of the angled insides and then the two parallel bases. So let's get into this. This is the most complex of all of the geometric shapes that we're going to be talking about the area for, because essentially what you have here is a rectangle in the center and then two triangles on the side. But these triangles, even though we look at this one and they appear to be the exact same size, or they appear to be congruent, equal, we don't know that for sure because we don't have the measurements on all of that. But what we do know is that if we had to solve for the area of this rectangle and then solve for the area of this triangle and the area of this triangle, it would take forever. So we have a formula that we could use that would make it a little bit shorter. Now, I don't want you guys to feel overwhelmed with this. We're going to work on this all week long and take it slow in baby steps, so don't panic about it. But the formula is area equals, to find the area equals half of the height times base 1 plus base 2. So this height line, this pink dashed line that we see in all the figures we've been looking at, that is not a real line that's on the shape. It is just sketched in for you so that you can tell where the height is at. So we're going to take half of whatever the height is, and then we're going to multiply it by this base and this base. We'll add those two bases together and then multiply it by half the height. All right. I just want to remind you before we do this that the parallel sides are always going to be your bases. So you're going to see different trapezoids and you might feel a little bit confused about which ones are the bases because maybe all of the sides will be labeled with numbers. The bases are always the sides that run parallel, the two that would never touch each other. So if they keep going, those lines keep going on and on forever, they will never cross or touch each other. So in this instance, again, we're using that formula, area equals half the height times base 1 plus base 2. So we've plugged in all the numbers here. Half of the height is 6, times base 1 plus base 2. So we do half of 6 times, and we're going to add these together, 14 plus 3 plus 10.5. We get this, 14.8. So half of 6 times 14.8. 6 times 14.8 is 88.8. Multiply that by half, which is essentially just dividing it in two, right? And we get our answer, area equals 44.4. There is a shortcut to this, and I'm going to share that shortcut with you in just a second. So I'm going to pause this video. I'll be right back. I'm going to get out my workbook. You should too, and open up to page 402. Okay, I'm back. I'm on page 402, and we're looking at this trapezoid. What I was talking about before is that you had to know that the bases were always the parallel sides, because sometimes they are not sitting like they were in my previous example. Sometimes they're tilted at weird angles, and so you have to be able to identify which sides are the parallel sides. So just to help you understand that, if we look at these two sides that are across from each other, if we continued these two sides on, they're going to meet and cross each other. So those are not our parallel sides. This side and this side, if we continued those lines on forever, they would never touch. They would never cross each other. So let's just refresh our memory of what the formula is for a trapezoid. Area equals half of the height times base 1 plus base 2. Okay, so we're going to go ahead and plug this in. A equals half. The height here is measured going this way. Okay, and I know that, and you will be able to identify it by that dashed line that was sketched in for you with the little right angle box that was put there. This pink dashed line always is the height. It's always indicating the height. So in this case, it's 8 times base 1 plus base 2. Now, if you look at this trapezoid here, we have it tilted. It's at a different angle than what we saw in the examples I showed you in the notes. So like I told you in the notes, you identify the bases by the sides that are parallel to each other. The sides that if those lines continued on forever, they would never cross, never touch each other. This side and this side, if we continued these lines on, they would eventually cross each other. So they are not parallel. These two sides, if they continue on, they will never cross each other. These are our parallel sides. What they did here was a little bit tricky, an extra step that they put in here for you. So we have one side, I don't care which is base 1 and which is base 2, it doesn't matter. This side is 12 plus this side, but what they only gave you was the measurement from this point to where the height begins. So they only measured this little tiny segment right here, which they said is 6 meters. You should look at that trapezoid and go, well, this is 12, and this whole side can't be 6. It's way bigger than this side. What they want you to do is add this little section that is 6, add it to this side, which is 12, okay? Because if this is a rectangle right here, then this measured 8, so this is 8. This measured 12, so this is 12. So you have to add these two pieces together to get the full measurement of this side of the trapezoid. So 12 plus 6 is 18. Okay, I hope you're following me on that. We're going to do more examples, so don't panic if you're not. So now you've got area equals, and this is where I'm going to put in the shortcut. Okay, this is what I think is the simplest to do and saves you some steps of work. So half of 8. I'm just going to do that right now. What is half of 8? It is 4 times 12 plus 18. Add that up in your head real quick. You should have gotten 30. Okay. And now you can go ahead and solve for the area. If you want to use a calculator, by all means, please do that. I don't have a problem with that at all. I'm going to get my calculator out, and I hope you can do this one in your head, but if you can't, 4 times 30 equals 120. So area equals 120, and the unit of measurement here is meters squared. All right, let's try it again. So we're using that same formula. Area equals half of the height times base 1 plus base 2. Our bases are identified by the parallel sides. So let's plug stuff in. The height is identified by the pink dashed line. I hope you guys can see this okay and it's not too bright or too dark. I don't know. Let me know if it's too hard to see. Maybe that makes it a little bit better. All right, so the height in this particular picture, it is 3 times base 1. Base 1, it shows us this full side is 7. And again, I don't care which you consider to be base 1 and base 2. It doesn't matter. You're adding them, so you're going to get the same answer no matter what. So 7 plus this side plus 4. Okay. All right, now in this one, we could cut the whoops, I forgot to put the half in. Half of 3 times 7 plus 4. I could cut the 3 in half, but it gives me a decimal. So if you're comfortable with that, you could do that, and then you would have area equals, just so you guys see where I'm thinking, 3 divided by 2 to get half is 1.5. 1.5 times 7 plus 4, which is 11. So put that into your calculator. 11 times 1.5, area equals 16.5, and the unit of measure is centimeters squared. All right, let's look at problem number 6. This is a kite, basically just a diamond shape. And this is going to be, there isn't any kind of formula that I can give you that's going to be quick or fast to do. They are a little bit time consuming, but you know how to do these because this is basically just triangles. You're just using triangle formulas. So when you're going to solve a problem that is a kite, you have to decide which way you want to divide up the diamonds. You could either cut them and have a diamond that goes like this, or you could cut it and have a diamond that goes like that. What I always recommend to students is when you cut your two diamonds, so if you cut it this way, you have a diamond here and you have a diamond here. You want to see that your diamonds have the exact same measurements because you're doing base times height and then divide by 2. That's the formula for a triangle. So you want them to have the exact same measurements if that's possible. So if we cut the triangles going this way, you would have a base that would be the same for both of them because that would be 6 plus 6, which is 12. So the base of the triangles would be 12. And then this triangle would have a height of 8, and this triangle would have a height of 9, which means you're going to have to do 2 problems. We don't want to do 2 problems. We want to do 1 problem. So if I cut my triangle this way, or cut my kite, I guess I should say, if I cut it this way, then they would both have the same base because they would share this base right here, which would be 8 plus 9. That would be how long this segment is, 17. And they both would have a height of 6. So we only have to do 1 problem and then multiply it by 2. I hope that makes sense for you. All right, so let's just go ahead and try to solve this then. Remember that the formula for the area of a triangle is half of the base times the height. So we're just going to worry about the top triangle right now. The area equals half of the base, again, is 17 because I have to add together both measurements, 8 and 9. So 17 times the height, which is 6. All right, so calculators are out. And whoops, I'm doing 17 times 6 divided by 2. So for one triangle, if you didn't catch that, for one triangle, the area equals, one more time, 51. And the measurement is feet squared. Okay. But we have 2 triangles, and fortunately, they both have the exact same measurements. For this triangle on the bottom, down here, the base is the same, right? 17, 8, and 9. And the height is also 6. So it's this exact same problem. So we have 2 triangles that both have the area of 51. So we're going to add another 51 to account for the other triangle. So the area for this kite is area equals, the grand total is 102. 102 feet squared. So when we look at these kites and trapezoids, the trapezoid I think is a little bit quicker than kites. They're a little bit time consuming, and you do have to put some thought into which way you should cut it so that you have the least amount of possible work. But you guys absolutely know how to do this because it's just triangles. Okay, so for practice today, I would like you guys to go to page 403, and I want you to try problems 7, 8, and 9. I will put a link in Canvas quizzes for you to enter your answers there, and then come back tomorrow or look at tomorrow's lesson, I guess, and I'll have a video there explaining how to do these problems in case you were stumped on it. If you have any questions, please reach out to me, swolf2@district100.com. Or join me on my live stream, and I would be happy to help you guys solve these problems and practice them there as well. I hope you guys are doing well. Everybody, take care.